So we heard a little bit today about some of the fast-paced movement to deploy AI, which runs on algorithms, but frankly, AI can't operate without the correct infrastructure, the correct power, the critical supply chain, and the minerals that are rare earths that are necessary to keep the physical infrastructure to support AI in place. As Northern Virginia's data center boom accelerates, industry and policy leaders have to tackle the urgent challenges of grid capacity, next-generation energy solutions, critical mineral supply chains, and frankly, resilient infrastructure. What's it going to take to power the AI revolution and to help us continue to accelerate the AI adoption at scale? To lead this critical conversation, we're going to welcome thought leaders, a stellar group of industry professionals who can speak to this. Clay Allsop, Public Affairs Manager for Google Data Centers. Shanthi, Muthiah, Senior Vice President and Energy Advisor at ICF. And Joe Woomer, Senior Vice President, Electrical Transmission at Dominion Energy. They are going to be led for moderation of that panel by Oliver Sadorra, Chief Growth Officer at Darkwolf. Please welcome our panelists to the stage for this vital conversation.
All right, oh, okay, there we go. So good morning. I am thrilled to be here once again representing Darkwolf, your signature drink sponsor, with our famous or infamous Darkwolf water, which I hope you'll stick around today to give it a try. Don't worry, it's on me. Thank you to David, Taryn, Gil, Jennifer, NVTC board and team for the opportunity to be here today. So let me start by saying AI is a fad. I've actually come up here the last couple of years and have said that here on stage, and I do say that in a joking manner. We've obviously seen AI become more and more prevalent across industry, society, government, and I'm excited to be here today with this esteemed panel to talk about one of the areas that I feel like doesn't get as much coverage. And David talked a little bit about this in his intro, and that's this topic of the AI build-out. Often when we hear talks on AI, it's about the technology or the implementation, industry needs, societal impacts, geopolitical implications, which I think which was discussed a bit on the last panel. But we're here today to talk about what it's going to take to sustain this AI wave and enable AI to keep advancing and evolving. When I think about this topic, one of the first things that I think of is the AI winter, or I guess AI winters is probably more appropriate, which, is everyone familiar with AI winter? It's basically this period between the mid-1970s and early 2000s where AI research and development stalled and faltered. And a lot of that was because we didn't have the infrastructure in place. We didn't have compute, we didn't have memory, power, and other resources to support these efforts. And so I feel like this is going to be a very exciting conversation because we get to talk about how we avoid that next AI winter and focus on what I like to call the 3 P pillars, say that 5 times fast: power, pipeline, and policy. So before I get started, I want to take a moment to offer an opportunity for our guests to introduce themselves and talk a little bit about their areas of expertise. So why don't we start with you, Joe?
Yeah, thank you, Oliver. Joe Woomer, Senior Vice President, Electric Transmission. So I've spent my career at Dominion Energy. We were talking earlier, this is my 40th May. I had a young engineer one day ask, his coffee pot and said, "How long have you been here?" And he's like, "It's my 2nd April." So now I just go in months with people. But I've spent most of my career in engineering, started my career here in Northern Virginia. I remember the first data centers that were put in. I remember AOL being down in Tyson's right here, and advancing out towards Dulles Airport, where we now have the world's largest data center concentration, larger than the next 5 markets in the U.S. And growing. So it's been a fun ride dealing with that from the very beginning to what we're doing today and innovating for that. So I've been on the operations side of the business, engineering side of the business, back and forth over that time period. And really, we were, again, before this conversation, it's the most exciting time to be in the energy industry is right now.
Shanthi.
Great. So I guess I quickly did the math. I'm on my 30th May, and pleasure to be here and on this panel. It's actually, probably in Northern Virginia, not so familiar with Dominion. You've probably never heard of Google before, but I'm sure all of you have heard of ICF. But for those, maybe just the 1 or 2 people who haven't, we're a global consulting and technology services provider firm. And we work across a whole host of industries, but energy, environment, health, all have been core to ICF, since inception over 50 years or so ago. I personally have worked and continue to work really in the energy space. And there, we're really working at the intersection of all the things that are relevant as we talk about AI, which is markets, policy, the engineering and the technology pieces of it, and how they all come together to sort of enable, this tremendous growth and these tremendous requirements. And so we do that with, long-dated market analysis, all the way from planning to implementation, and thinking about how all of the different players in the ecosystem, need to come together. So we work with utilities, we work with the developers, we work with the investors, we work with the hyperscalers, and importantly, also with, state and local government and federal government. So with that, I'll turn it over to Clay.
Thanks, appreciate it. I'm approaching my 40th May in life, so catching up, but I appreciate the opportunity to be here. So Clay Allsop, I'm with Google. I work on the global infrastructure portfolio, and my public affairs region is the Mid-Atlantic. So I tend to focus my time on local government. That's where most infrastructure is built, but anywhere where we want to build out digital infrastructure, which largely includes AI as well as cloud compute.
Great. Thank you, everyone. So why don't we start the conversation around data centers? After all, you alluded to this, Joe, we're in Northern Virginia, which is often dubbed Data Center Alley. So as many of the data centers were stood up during this cloud computing era, what do you see as some of the challenges of adapting the existing infrastructure of data centers for these AI workloads, these new AI workloads and AI compute?
Yeah, great question. I mean, you start out thinking these data centers were fairly small when it started out. They were 5, 10, 20 megawatt sites. The new data centers that are coming in to being here, each building's about 100 megawatts apiece. And so we start talking about gigawatts instead of megawatts. Think about what is a gigawatt? If you're not in the power industry, you think about the city of San Francisco, all the residents, commercial, industrial in San Francisco is about a gigawatt. So now we start talking about that. The challenge is to feed that need. And, it took 25 years for Dominion Energy to get to 25 gigawatts. We're going to double that in the next 10 to 15. So how do you do that? It doesn't happen without innovation and efficiencies. So you have to be doing that. So from a generation perspective, we've got to look at an all of the above strategy. We have nuclear, we have gas, we have the fossil, we have a huge renewable portfolio. We're now pulling power off the coast of Virginia Beach from our offshore wind. So you're taking an all of the above approach. I was recently at a conference with our CEO, and he was talking about all of the abovest. Where's fusion? So we've got Commonwealth Fusion wants to locate their first commercial plant in Chesterfield, Virginia. which would open up a whole new dynamic for the power industry. So you do that, and then you have to look at the transmission and all the infrastructure. And I feel the pain of citing everything that, when we think about citing new transmission infrastructure, we're citing new data centers. So we have to leverage our existing rights of ways to bring more power in. So we upgrade our 500 kV loop and get about 150% more capacity out of that by using advanced conductors. But then 2 years ago, to feed that data center demand, we entered a joint venture to bring 765 kV into the area for the first time. And we have some challenges there because you're citing new infrastructure and a new right-of-way. But that's going along well, and we're proceeding with that. And then just last year, we submitted a proposal to bring HVDC, the first HVDC interregional project, 525 kV plus or minus DC underground, into the PJM zone, and we're awarded that project. So it's all about how do we get that capacity in there. And then with AI, we have to work with the data center community to make sure that we can maintain the reliability. So we have to make sure that those loads that can vary very quickly do not cause other reliability problems for data centers, for our residents. It's all about how we can make things work together. And we're using StatComs and new tech fax devices on our transmission system to try to keep those electrons flowing in a organized fashion to you, the customer, whether it's your home, your business, or your data center.
Appreciate that. I was chuckling a little bit when you were talking about gigawatts, and who can name name what movie this quote comes from? 1.21 gigawatts, right? Yeah, we're talking 1.21 gigawatts to power a time machine, and I think it was OpenAI that mentioned something along the lines of they're expecting something along the lines of 30 gigawatts by 2030, and that's just one of the players in this whole AI industry. And I actually want to get some of your thoughts, Clay, on how Google is doing its part to help the energy sector kind of balance this, as Joe alluded to, this balance between AI workloads and the effects on the national and regional grid.
Yeah, thanks, Oliver. Appreciate Joe's comments. I used to work at a power utility as well, and so I remember seeing the first hyperscaler data centers coming in, and we were so excited for the base load, and then all of a sudden 30 more came in, and all of a sudden we were like, how can we generate the base load? Google's there to partner with our utility providers, and we were the first to develop clean energy PPAs with some of our utility partners. So in the last 20 years, we've procured 22 gigawatts of clean energy. Just for scale, Joe talked about San Francisco. California peaks at about 50 gigawatts. So that's how much we've procured to power all of Google's infrastructure. And that's important to remember. The two most visited websites on the internet are google.com and YouTube. So it takes a lot of resources to power those. How do we help balance the load? What I think is new and coming up today is demand-side management. And if you look at the way the grid is built, it is built for the peak 1%. So I used to live in Arizona, and that would be about 90 days in a row where it would be 110 degrees above. And the grid was built to sustain that, while the other 99% of the time, the grid was overbuilt. And data centers are the same way. They're overbuilt to keep the load going. And that is everything that everybody's doing right now on their phones. That is your business. That is hospital networks. So we provide a critical product that does not accept any downtime. But the demand side management creates an opportunity where we can scale down our load to leave capacity on the grid. And in some cases, we've been able to leave hundreds of megawatts on the grid, which would be the equivalent of maybe a couple of gas turbines. So perhaps you can not turn on those gas turbines, and Google downs their load temporarily during peak events.
That's great. I want to expand on this idea of stability and effects on the grid. You know, there have been talks about some of the big players separating out from the grid by implementing their own energy sources to include natural gas. You mentioned, Clay, alternative energy resources as well. Why don't we start with Shanthi? How will these alternatives be able to help keep up with this demand?
Yeah, I think you talked about all of the above solutioning. I think there's for each period in time there's sort of a different set of all of the above solutioning. So if you look at the next 5 to 7 years, that's where I think the grid capacity is most constrained, and you have a potential in many regions to have that supply-demand mismatch. I think if you look at PJM, which is the market that we're in, we see clear evidence of that in the last capacity auction. It cleared with a shortfall. And so we are having to look at other solutions, and those solutions include on-site generation. They include, demand flexibility. I think in this situation, it is very much bring your own generation or bring your own flexibility. And so with on-site generation, I think that it is one of those solutions that is critical in the near term. We are seeing it being increasingly deployed. But I think there is also a clear prevailing view that it is not a viable long-term solution. I don't think we're going to end up with a situation in which you've got the grid and then you've got these islanded independent systems. These islanded independent systems aren't viable because they tend to be cost inefficient and operationally inefficient. To be able to serve load that's typically close to 24/7 reliably, you can't just have sort of a one-for-one match for on-site capacity and on-site load. You often need multiples of load because you are going to have to go down for maintenance. There'll be variability, et cetera. And so it is an important bridge, but it's not a destination, right? And so what we're seeing is a combination of on-site generation to meet that near-term speed-to-power issue, and then curtailable grid connection as a piece of that puzzle, and then eventually working towards full grid integration. And I think that it's that hybrid connect and manage approach which is what is really emerging. And it's bringing together all of these different facets. I think in terms of on-site generation, gas is certainly the most viable solution right now, and that whether that be IC engines or peakers or even combined cycles. And that's because, again, it's providing that reliability attribute that is so needed. And even there, it's having to be paired in many cases with storage for balancing load and some of the stability requirements. So I think that it's really a hybrid model that's emerging, and scalability of on-site generation I think has some of its limitation. But I would echo what Clay said earlier in terms of an innovation area. Trying to work with less rigid load, more flexible load is certainly a part of the near-term solutioning as well, and we've seen a lot of innovation in that area.
I love that, and I mentioned the 3 P pillars, like I like to call them, and so I kind of want to close out this discussion around power, and I'd like to maybe get a hot take, and I feel like I know the direction that everyone is going with this, but feel free to chime in on your thoughts. In 1 to 2 minutes, how much of the solution is around efficiency and innovation versus raw power generation?
Starting with me?
Yeah, why not, Clay?
I love that you asked for 2 minutes. This is the one I could talk forever on. Our hardware is about 30% more efficient than it was 6 years ago, and it has about 6 times the compute. So we've had incredible gains in efficiency, but those gains in efficiency have been outpaced by the load demand curve. So if you look at our sustainability goals, we're actually further away from achieving those today than we were several years ago. So it's got to be all of the above. We need more innovation. We need more generation because we certainly don't see the demand curve going down.
I guess I'd just say there's really no long-term substitute for raw generation, and that's because I think with the pace and magnitude of demand growth, it just requires such scale. I think efficiency plays a really important role, but I think it's an incremental role. It's a complementary role. But again, both everyone here has talked about the gigawatts of demand growth, and it's really tens of gigawatts of demand growth. And so I think that all of the activity that we're undertaking to address near-term needs has to be done in concert with preparing for, sort of that longer lead time raw generation, and importantly, the wires and the substations that are also required to support that generation. But what's exciting is that I think that there's a lot of innovation underway even on the generation side in terms of advanced nuclear and geothermal. So I think it's not going to solve the near-term problem, but I think that from a clean, reliable, firm, dispatchable perspective, as we get to the 2030s, there will be more options, and so there's continued efforts and progress that needs to be made on that front as well.
Yeah, when Clay was talking about efficiencies, I had one of my vice presidents that used to quote Jevons paradox: the more efficient you get, the more you use of that product. And that's what's happening out there. We currently have about 70 gigawatts of requests in our planning model. We're working 25 gigawatts of execution today. As I said, we'll hook up more data center load in the next 5 years than we did the previous decade. And I believe that what will happen is 5 years after that, that will continue. But when we think about efficiencies and innovation, I think about battery technology. David and I were having a conversation in the hallway. Today's battery technology won't solve what we need. We need new chemistry, new innovations, so that we have a more efficient, long-term duration storage that is only 25% efficient on a round trip is not something that's going to solve our issues. We need something that's more efficient on round trip, because it doesn't generate. It's a load and a load reducer, but it depends on what time of day or what time of the year it is. So you need to be able to cycle that. We have the free world's largest battery in our Bath County storage. I'm very thankful to my predecessors that built that. We can generate 3 gigawatts. I watched on a peak winter day. We're generating out of that. When the sun came up, the solar started to come in, and we were able to back that off. But I think collaboration is the word I would use that we need. We need collaboration with industry, with the data centers, with our partners out there to find a way to the yes. We need to be. I spend a lot of my time defending. They say we're an impediment to advancing AI.
Yeah.
We're an enabler, but we need to do that together as a community. We only succeed as a community, and that's where I think we have the opportunity, is that collaboration. That's what's going to make the difference from today to tomorrow.
I really appreciate that, Joe, and I know, Clay, you alluded to this earlier about Google partnering with companies like Dominion. I think that's probably the trick answer to the question, because I didn't mention anything about partnerships, but obviously both of you and Shanthi as well kind of highlighted the importance of partnership. But let's now transition to the second P, which I call pipeline, but it's really referring to supply chain. It was recently reported that half of the U.S. data center builds this year have been delayed or canceled, and a lot of that has to do with the shortages on infrastructure parts, and a lot of those parts are coming from China, who also controls much of the global rare earth minerals. What can we do to get some of these projects back underway? I don't know if who wants to start with that.
Well, I can start. From a supply chain. Supply chain was one of the long poles in the tent for quite a while. Number one, our military and defense folks that were in here earlier, we avoid Chinese manufacturers. as far as our transformers and our breakers and our critical equipment that's out there. But we do have great partnerships. We have slots for long lead time. Siting and permitting is really become a big issue. When you have to go through and you're siting a new transmission line, you're siting a new generator, you're siting a new data center, I think, Clay, you would agree, we have to be better at helping people understand the benefits. My siting team, I had a breakfast with them the other day, and a couple of them had come over from another industry, and they used to think that Dominion could just do anything they wanted. And they said, I learned very quickly that wasn't the case, but the community outreach that you have, you have to be a good listener, empathetic, understand, and maybe make some adjustments to your plans. That you might have a great plan, but just like in a battlefield, you have to adjust the plan as you go if you're going to be successful. And the siting has become one of the biggest impediments to getting projects done quickly. So as we move forward, we have to work together again in that area. And I was at a data center conference recently, and again, I keep coming back. I'm a collaborator, so it's like we can't go out and help a data center get their siting, but we can have the talking points and I tell my team all the time, what do we get out of a data center? Even a farmer is using, data to help advance the farming. And they were talking in the earlier panel, I hear human in the loop. I don't quite prescribe to that. I think it's AI in the loop. AI is a tool for us to make us better. The human doesn't need to check the AI. The human needs to leverage the AI to get a go ahead. And so the permitting is the biggest challenge we have.
Yeah, I would agree in terms of process. There's a speed issue in terms of execution, but there is, as you said, also a physical, infrastructure issue in terms of supply chain. I'm sorry, in terms of supply chain constraints. I think we entered this AI era already sort of backlogged from the COVID era disruptions, from sort of multi-year underinvestment in infrastructure, and so we were coming from behind, and now we're only adding, in some sense, to that hold. So I think it's the Dominions of the world, and maybe the APs, and sort of some of the big utilities, and maybe some of the big hyperscalers can get transformers and some of the other switchgear circuit breakers maybe now in that from what I've heard from equipment suppliers, in that 2029, 2030 timeframe. But there's a lot of other players in the space, and they don't have that advantage, and they're a couple years behind that. So I think, it is very real, the supply chain constraints, and I think that if you're limiting it in terms of, global access for, in some cases, good reasons, in other cases also for tariff reasons, there are some, limitations that, are real impediments at this time.
The one other thing I would add to that, we've working with every one of our vendors to onshore as well. We've had expansion down in Virginia at the transformer plant down in South Boston. There's been expansion down in South Carolina and North Carolina. So the closer we can get that takes away some of the issues that we have with tariffs and things like that. But they need a clear signal that this is not a flash in the pan. They're not going to invest capital money, whether it's in Korea or in Japan or in the U.S., if they don't have a clear signal that investment is going to have a long-term return. And we work very hard to give them that signal.
So I wanted to add a couple of things. We see the same challenges in the supply chain, critical minerals. A couple of anecdotal examples of what we're trying to do to help mitigate those problems. You talked about the batteries, and we just recently partnered with a utility in Arizona for long duration energy storage, iron flow battery. And the technology today is still somewhat new and not extremely effective, but somebody needs to start investing that money to be able to get the technology to a place where it's scalable. And we see a future there with those flow batteries, because the batteries are really critical. If you've got a lot of inverter-based resources on the grid, you need batteries to even that frequency out and modulate the power coming in. And another one I don't hear a lot of people talk about, it's a real issue, is the SMR fuel supply chain. We all talk about SMRs, how important they will be, and they undoubtedly will. But it's a chicken and an egg issue. Who's going to build the generation without the fuel? Who's going to develop the fuel without the generation? And just almost 2 years ago, Google invested and purchased 500 megawatts of Kairos SMR power, which gave them the funding to be able to develop the fuel pellets necessary to create a plant that would be able to be commercialized. And that's still years out, but I think Google's looking at these things 5 to 10 years out. How can we be a player here and advance the technology that will help our data centers continue to run?
Could I just add one point? It just made me think about it. I think there's constraints, as you just mentioned here, across the full infrastructure stack. So even going back to natural gas, it's not limited to the physical equipment. It's also fuel access and fuel supply. And so there's, that extends over into, building pipeline capacity, et cetera, that's needed. So it's unfortunately broad-based. I think there is solutioning across the board and focus there as well. But it's not limited to just, a couple elements.
I want to close up this discussion around pipeline with something that I think actually ties into policy a bit, and do another one of these hot takes. So, feel free to answer if you have any thoughts on this. But how effective do you think things like the CHIPS Act, and the CHIPS Act is the act focused on it's mostly focused on semiconductors, but bringing those capabilities in-house and producing them domestically, how effective do you think something like the CHIPS Act or other similar types of legislation are affecting the ability to supply infrastructure parts in-house?
I could start. I don't know. It wasn't well known several years ago that Google was producing its own chips. It was out there, but I don't think it was as well documented as it is today. Our data centers use NVIDIA chips, their GPUs, and we use our own in-house TPUs. I couldn't tell you how much the CHIPS Act impacted our production line, but I do know that we're relying on Taiwan semiconductor chips to supply some of our production. So I lived in Arizona. TSMC was just a few miles away from my house. That had a huge impact on the tech sector, being able to get a reliable supply of more than just chips, but everything across that supply chain. So, at the federal level, I don't see huge impacts on data centers. As I said in the beginning of this conversation, infrastructure is largely done at the local government level. So I see state and local government policies impacting infrastructure much more significantly than I see federal policy.
All right, so let's maybe dive into policy, and I'm glad you talked a little bit, Clay, about local policy. So, Northern Virginia, bringing it locally, is sort of at this, I would say, density threshold. How do we start evolving this conversation with local communities and to help navigate their perspective on supporting the power demand, land, water, towards some of this data center expansion? Maybe I'll start with you, Joe. What's your perspective from a Dominion standpoint?
Yeah, I think the thing that we need to do a better job is talk about how we are trying to be that good corporate citizen, the good community citizen. With the 765, for instance, in order to deliver that amount of energy with a 500 kV line, we would have had to build 3. So you think about 3 wide versus 1 that's just a slightly larger than the other one. So that's where I think you get into some of the efficiency. But we have to be able to talk through that. Everybody wants it to be underground in our world. But when you're trying to move that huge amount of power underground, it is very costly, and affordability is, I hear it everywhere. It's part of our mission, but I hear it at the local levels, as Clay was talking about. I hear it coming from the federal level, from FERC, and from our own state regulators. So I think it's just, we got to meet and just have those rational conversations on what we're doing to minimize it. I mean, I think about the data center community, and we had this. Live in Hanover County now, and there's a few data centers down there, and I'd love to get a couple data centers in, and people worried about the water and everything. And I know that the water consumption of an early data center is very different than the water consumption of a new data center. Those are the kinds of talking points that the data centers arm us with, so that we can help dispel the myths. I think the same things have to happen on the power side. People have to understand and dispel the myths that are out there so that we can get this infrastructure built.
I love that.
Yeah, I really echo that. I think
Shanthi,
Mike.
Sorry about that. I think that there is a lot of education that's required, and sort of early engagement and transparency and communication that's required. I mean, that is clearly, one great thing about Northern Virginia is that we've had a lot of experience with data centers, and so there's been a lot of, we've moved up the learning curve in Northern Virginia, and can apply some of that learning both locally and broadly. And I think it's clear, we've evolved from a lot of development behind the scenes, and then sort of surprising communities is not the way to go, and have moved towards that early and transparent engagement, where communities have a chance to be at the table, be clear about requirements, and understand and talk through sort of trade-offs and benefits, and be able to sort of more proactively inform and influence some of the outcomes, as opposed to just sort of reacting to them. So I think that sort of dual, way conversation is key as well, and we've seen that be more and more effective.
I think also at the local level, policy is driven, by the squeaky wheel. And some of that's from bad information. And I always look at it as my job, not really to change people's mind, but to give them the information and the facts to be able to make up their own mind. Some of those misnomers are that an AI query takes gallons of water. I think we're the only hyperscaler that actually measured it and published it. It takes about 6 drops of water. So I think it's up to each of us to decide if that's worth it. Sorry, I'm referring to revenue. Revenue into the local government is also something that hasn't been talked about a lot. I think you're going to see a lot more of that. So just Loudoun County is an anomaly, and we're not going to see a Loudoun County 2.0. I think the industry has matured and grown since then, but Loudoun County has also decreased their taxes every year for the last 10 years. Mecklenburg County has decreased their taxes. They've funded $150 million school projects without any of that burden falling on the backs of residents. Bottleneck County, because of Google's recent purchase of land and future investment, has bought fire trucks, new police vehicles, 911 systems, and maybe most importantly, pickleball courts. So these are the types of things, the benefits that come to the community. I think a lot of times we need to be better about telling our own story and helping people understand the benefits that come in terms of jobs, in terms of tax revenue, and workforce development.
Pickleball is, sure winner right
Number
there.
one.
Yeah.
Yep.
Actually, you brought up something in that conversation, Clay, that I'd actually like to talk a little bit more about, and this is really the elephant in the room, and that's the effect that AI is having in the job market. And looking at our discussion today, or hearing our discussion today, it looks like there's a lot of opportunity though for job creation around this AI build out. So what are some of the thoughts around the effects that AI build out could have on jobs, and what are some of the in-demand skill sets?
Well, I can speak for Google in terms of in-demand skill sets. We're seeing, not just Google's not seeing this, I think in the industry as a whole, we're seeing a renaissance in skilled trades. And every project that we have, we cannot get enough skilled trades, whether that be electricians, linemen, plumbers, every aspect of construction. And these union groups and other skilled trade companies, they are getting pulled everywhere, and the price just keeps going up and up. And so it's wonderful for these people in these non-traditional four-year degree programs. My wife and I joke, we were like sold on this four-year degree is going to be the thing that will save your life. And it worked fine for me, but it doesn't work for everybody. And so we're providing an opportunity for people to take a different path. There's a lot more need, and so we are participating in workforce development programs where we pay for students to go through apprenticeships. We pay them for their time, for the resources, and they're free to go wherever they want. We'd love for them to come join Google and build one of our data centers, but that's just one response that we have to the lack of skilled trades in the broader workforce.
I guess it's known that there's a lot more jobs in the construction phase as opposed to the operating phase of the data centers. Right, could be hundreds, could be thousands, and then much more scale down in terms of operation, but still requiring specialized expertise. One of the things that I think we're seeing increasingly, or the potential for, is data center clustering, and that not only just for sort of latency reasons, but because you can then develop, a workforce that is sort of sustainable and has a base. And so I think that there are some ways in which we can encourage development that is positive towards, creating these resilient, sustainable workforces, even if in operation there are fewer people. But at the end of the day, I think jobs is just one aspect. I think, broader economic growth, economic development, tax revenues, as you mentioned, these are other things. But I think, again, there are some real trade-offs. There are just the one last thing I'll say in terms of benefits for communities. There's also, with the development of infrastructure and transmission and roads, et cetera, in an area, there are newer standards that are being applied, and so there's actually better, resiliency and reliability that these local communities may also be able to benefit from. So again, it's not that everything is positive. I think there are trade-offs, but again, being clear and transparent about all of those facets, and then allowing communities to be more informed to make decisions, I think is really key.
Yeah, I agree with those statements. I think one of the problems we get in our society today is we have these binary reactions to everything. We're going to lose all these jobs, we're going to gain all these jobs. It's really something different. And if you think about, mentioned farming earlier, farming is very different today than it was 50 years ago. It's not an easy job today, but it's a completely different job when I'm in a tractor that's air conditioning, guided by GPS and everything else. Same way with our craft labor that I think about, whether it's our system protection folks that are dealing not with electromechanical relays, but the programmable logic controllers using fiber optics for communications between devices instead of old copper wire. So we're decreasing the amount of that. All of our craft labor are also becoming higher skilled, and that is better for us as a community to have these high skilled folks. You think about even the old auto mechanic, you used to be you do your own work on your car. Now it's a piece of technology. It's not so it takes a different person, and it's an upskill, and it's a better life, and it's a better job. So our linemen out there, our technicians out there, our planners are using different tools today. Our project management, is using different tools. They're not using pads and Excel spreadsheets anymore. So I look at it as a benefit. It takes away some of the burdensome work, and hopefully makes life more fulfilling for our teammates.
Yeah, I chuckle when you talk about auto mechanics and cars, and I'm sure David can attest to this with his Tesla. I feel like my car is basically a mobile data center, and you need the proper folks who can work on that mobile data center. So we are coming up on time here, and it's amazing how time flies, and it's been such a great conversation. But does anyone have any kind of closing thoughts about this whole AI infrastructure build out? Just some general thoughts or ideas about how we can move forward.
Yeah, I'll say, just to be brief, I have a lot of hope in where it will bring us. I know there's a lot of questions and concerns about that, and that's okay. I understand where that's coming from. I think representing Google has been nice because I can genuinely say we're trying to do data centers and AI the right way. And I also want to emphasize that it's a maturing industry, and we're learning as we go. And the more we engage with people, I think the better we're able to accomplish that.
Yeah, I'll just add to that. I think it's daunting on the one hand, but it's actually a great opportunity. I mean, I think from a grid and an energy system perspective, it's giving a real infusion to what was needed in terms of investing in the grid and having now more demand that is able to carry some of that burden and the cost burden. So I think that we can see it as a great opportunity to sort of take the grid and the energy system forward, and it's giving us opportunities to really invest and explore in some of these newer technologies that get us to our sort of our ideal in terms of clean, firm, reliable power.
Yeah, I like that reliable power. That's the one thing that we can't lose. We need, I think Katie was talking about advancing AI, but also doing it in a secure way. We also have to do that. We have to advance the grid. The Eastern Interconnect is the largest machine in the world. It has to work together from the generation through all the transmission through the load. It has to match every millisecond of every hour of every day. We have to do that reliably. And we cannot forget that. But we have to add speed to it. And I think we have a mutual interest in that amongst the community.
I think that's something we could actually spend another hour talking about. But we are just about at time, and I know we're standing in the way between us and lunch, so I don't want to go on too much longer. But I want to thank everyone from the panel here and getting their thoughts and ideas today about the AI build out.
Thank you.
Thank you.
Thank you for